So this was the problem we had. Okay. Determine the amount of heat which should be supplied to 2 kilogram of water. Determine the amount of heat, which means amount of heat എന്നുള്ള term എന്താണ്? Amount of heat means it is not entropy അല്ല. It is not entropy. It is not volume. Volume അല്ല entropy അല്ല. So it is determine amount of heat means temperature ആവാം അല്ലെങ്കിൽ enthalpy ആവാം, right? Determine amount of heat. Amount of heat എന്ന് വെച്ചാൽ ഒരിക്കലും temperature ആവില്ല. Okay. Amount of heat means enthalpy ആണ്. Enthalpy H. And the total heat, which is Q. Q എന്ന് പറയാം. Q. Determine amount of heat which will be supplied to 2 kilogram of water at 25 degrees Celsius. So, a particular amount of water is there at 25 degrees Celsius. It's at 2 kilogram. It is to convert into steam at a 5 bar and 0.9 dryness fraction. 0.9 dry means dryness fraction X value. So given the mass of water to be converted is 2 kilogram. Temperature of water is given as 25 degrees Celsius. Pressure of steam is given as 5 bar. Dryness fraction is given as 0.9. So we have our steam table with us. Steam table and Mollier diagram with us. Okay. So steam table, the name itself indicates that it is the property of steam, saturated steam and superheated steam. So we want to obtain to compare the value or to get the value from the particular steam table, you want to take the values of particular steam. Steam in the values of the right? So here the value for steam is given, pressure of the steam is given 5 bar. Pressure of the steam is given as 5 bar. So take your steam table with the 5 bar pressure. The 5 bar pressure and the readings are what that VFG, VG, SF, SFG, HE, etc. Anything is there. So here we equation data. So here we want to know, we want to obtain particular maximum value or an amount of heat to be supplied, means it is the total amount of heat. So total amount of heat ഒരിക്കലും വോളിയം അല്ലെങ്കിൽ എൻട്രോപ്പി ഇൻക്ലൂഡ് ആവുന്നില്ല. സോ യു നോട്ട് വാണ്ട് നീഡ് ദ വാല്യൂസ് ഓഫ് SFG, SF എഴുതി വെക്കാം, ഇത് കൊണ്ട് തെറ്റുന്നില്ല. SFG, VFG, etc. We are not need to write the particular values. Here we only need the value of HFG, HF or HG. HF, HFG, HG. Enthalpy value you only need. Okay. അതെങ്ങനെയാണ് നമുക്ക് ക്വസ്റ്റ്യൻ ചെയ്യുമ്പോൾ മനസ്സിലാവും. സോ നെറ്റ് amount of heat you want to find to determine amount of heat means the amount of heat of steam, enthalpy of total particular steam minus initial temperature of water. That's amount of heat should be supplied to volume of water. Initially a particular water have possesses something as a small heat. Any water initially there will be a amount of heat. So enthalpy of total steam minus that particular amount of heat will be the increase in amount of heat to change the particular liquid into water. Achieve മനസ്സിലാവും. So take your data book at steam table and write down the particular values related to the particular 5 bar pressure. 5 bar pressure is 5 bar, right? So it is temperature rated table, and thereafter there is a pressure rated table also. Pressure table 5 bar. 5 bar. Here it is 5 bar. Put in the 5 bar. Okay. So write down the particular readings of suitable needed terms. Needed. So if you don't know what about need you can write any value, every value of particular section rated to 5 bar. So here we need I told that we only need the value of HF, HFG, HG value. HG, HFG, enthalpy value only we need, because that we want to find the transfer of heat only, not entropy related with it and no volume related with it. So if you want to need all the particular values, you can write all the values. So here we only need the enthalpy values only. So pressure from steam table according to pressure 5 bar. I don't from according to 5 bar. I don't need it. I don't the readings, that is HF value, HG value, HF value, HG value, and HFG value, that is 640.1. 640.1 here, according to 5 bar, 640.1 unit is given here, kilojoule per kilogram. 640.1 kilojoule per kilogram. HFG value 2107.4 kilojoule per kilogram, and HG value is 2747.5 kilojoule per kilogram. If you need, you can write all the values just shown here. It is entropy value, SF value, SFG value, HG value, and VF value, VG value, etc. So, okay, 640.1, 2107.4, 2747.5. Okay, then come to our particular section. After writing the particular values, that is HF value is 640.1 kilojoule per kilogram. HFG value equal to 2107.4 kilojoule per kilogram according to 5 bar from steam table, according to 5 bar pressure. You want to write the particular HG value with that. HG value. Then come to your particular equations. That is, you want to, as I said, that the total amount of heat needed to ഒരു അടങ്ങിയിരിക്കുന്ന വെള്ളത്തിൽ, അതാണ് നമുക്ക് കയ്യിലുള്ള ഒരു വാട്ടർ. If we have a particular water here, it should be have something heat. ചെറിയൊരു ഹീറ്റ് എന്തായാലും ഇതിനുണ്ടാവും, initial heat. So that particular heat can be calculated by using equation NC delta T. NC delta T will be the particular amount of heat initially that particular water will possess. Okay, that is sensible heat. Sensible heat. It is sensible heat which a particular water have initially. Okay, so total heat കണ്ടു വെച്ച് കഴിഞ്ഞാൽ ഇത് ഹീറ്റ് കുറക്കണം, എന്നാലേ amount of heat which will be needed. പിന്നെ വേണ്ട ഹീറ്റാണ് ചോദിക്കുന്നത്, ഇനീഷ്യലി ഉള്ള ഹീറ്റ് അല്ല ചോദിക്കുന്നത്. The question is asking like that, you want to find the amount of heat required to transfer, that is additional heat you mean to transfer. So a particular enthalpy കണ്ടുപിടിച്ചിട്ട് minus that particular value want to be find out, that MC delta T value കുറക്കണം, എന്നാൽ മാത്രമേ നമുക്ക് amount of initial കിട്ടുള്ളൂ. So first you find the enthalpy of steam, enthalpy of 1 kilogram of steam. So enthalpy of steam, enthalpy of 1 kilogram of steam, enthalpy of 1 kilogram of steam. So if a question is asking like that, you must first find out the enthalpy of steam minus initial temperature of water. Enthalpy of heat means H. Enthalpy of steam, H equal to, what was the equation for H? HF plus HFG. HF plus X into, if Reynolds fraction is there, you can write HF plus X into HFG. XF plus X into HFG. It is the equation for H, enthalpy. HF plus X into HFG. That is, HF is from steam table, X is given in a question, HFG is also given from steam table. That is 640.1 plus 0.9 into 2107.4 will be given kilojoule per kilogram. That particular value enthalpy. ഇത് 1 കിലോഗ്രാമിൻ്റെയാണ്, നമുക്ക് വേണ്ട കിലോഗ്രാമിലേക്ക് മാറ്റണം. ഇനീഷ്യലി ദിസ് പെർട്ടിക്കുലർ ക്വസ്റ്റ്യൻ HF equal to HFG plus XFG എന്ന് പറയുന്നത് മാസ് 1 കിലോഗ്രാം ആകുമ്പോഴാണ്. സോ നൗ മാസ് ഈസ് ഇൻക്ലൂഡിംഗ് ഹിയർ, മാസ് ഈസ് ഈക്വൽ ടു യൂണിറ്റ്. സോ here you want to find the 2 kilogram. So thereafter last finding the amount of heat, multiply it 2 to get the 2 kilogram of water. These all values are HF equal to HF in the value, SF, VF, everything is related to specific value, that is mass equal to 1 kilogram. So if you want to find the above 1 kilogram, initially you must find out the 1 kilogram of particular value and multiply any needed value. So here the value will be 2536.76 kilojoule per kilogram. ഇതെല്ലാം ചെയ്തിരിക്കുന്നത് മാസ് 1 കിലോഗ്രാം, മാസ് യൂണിറ്റ് എന്നുള്ള ഇക്വേഷൻ വെച്ചിട്ടാണ്, ആ ഒരു ഐഡിയ വെച്ചിട്ടാണ്. So if you want to find out the more kilogram of water section, you want to just find out the initial unit value and multiply that particular amount. Then you want to find the sensible heat of water. Sensible heat of water for 1 kilogram, right? For 1 kilogram. So mass is taken as 1. It is mc delta t. mc delta t. Here there is no change in temperature. Initially വെള്ളത്തിനുള്ള ടെമ്പറേച്ചർ ആണ്. ഇനീഷ്യലി വെള്ളത്തിനുള്ള സെൻസിബിൾ ഹീറ്റ് ആണ്. അപ്പോൾ അവിടെ ചേഞ്ച് ഇൻ ഹീറ്റ് ഒന്നുമല്ല, ഇനീഷ്യലി ഉള്ള ഹീറ്റ്. ഡെൽറ്റ ടി എന്ന് പറഞ്ഞാൽ ടി തന്നെയാണ്. ദാറ്റ് ഈസ് എത്രയാണ് തന്നിരിക്കുന്നത്? 25 ഡിഗ്രി സെൽഷ്യസ്, റൈറ്റ്? 25 minus 0. 25 minus 0. Okay, initial temperature only. There is no change in temperature here. Though delta t is t itself. So m is taken as 1. C means Cw. This Cp of water. Cp of water. As I said that for water, Cp value will be taken as 4.18 kilojoule per kilogram Kelvin. For air, we have taken at 1.005 kilojoule per kilogram Kelvin. So water, the value of Cp is 4.18 kilojoule per kilogram. If it's not given in a problem, you can assume it. 4.18 kilojoule per kilogram Kelvin. For some question, it is given. mc into delta t. Delta means 25 degrees Celsius. 25 എടുക്കാം. കെൽവിനിലേക്ക് മാറ്റണം. 25 minus 0. That is 104.5 kilojoule. 104.5 kilojoule. Okay. So net heat to supply to change into steam. Net heat applied to change in steam is enthalpy minus sensible heat, right? So enthalpy of steam minus sensible heat of water. Initial heat of water. Sensible heat, that is 2536.76 minus 104.5. 104.5. That is 2432.26 kilojoule. 2432.26 kilojoule. So this amount of heat is required to applied to that particular water to change the mass of 1 kilogram of water into steam. അല്ലെ, നമ്മളിപ്പൊക്കെ ചെയ്തെന്താണ്? യൂണിറ്റ് മാസിന്റെ കാര്യത്തിൽ എടുത്തത് അല്ലെ. ഇതൊക്കെ യൂണിറ്റ് മാസാണ്. mass is equal to unit here, 1 kilogram of steam, and here sensible heat of 1 kilogram. So everything is related to 1 kilogram. So net heat is to change 1 kilogram of steam to steam. So net heat supplied for water to change that particular 1 kilogram of water into steam is 2432.26. And next, for 2 kilogram of water, question is like 2 kilogram of water. 2432.26 into 2. That is the amount of heat required to transfer 2 kilogram of water into steam. So ഇതുപോലത്തെ 2-3 ക്വസ്റ്റ്യൻ ടെക്സ്റ്റ് ഉണ്ട്. ദാറ്റ് ഈസ് ടു ഇൻക്രീസ് ടു ചേഞ്ച് ഒരു വെള്ളത്തിന് തന്നിരിക്കുന്ന ഒരു വെള്ളത്തിനെ ടു സ്റ്റീം ടു കൺവേർട്ട് ടു സ്റ്റീം എന്ന് ചോദ്യം വന്നു കഴിഞ്ഞാൽ യു മസ്റ്റ് ഫൈൻഡ് ദി എൻതാൽപി ഓഫ് സ്റ്റീം ഫസ്റ്റ്. Enthalpy of steam by taking the value from steam table, and that value that particular value will be a maximum value, and you want to subtract the sensible heat of particular water from that particular enthalpy to calculate the amount of heat required to supply it. Sensible heat is mc delta t itself. mc delta t will be t itself. m is taken as unit. For 1 kilogram ആണ് ചെയ്യുന്നത്, m is 1. So that is the problem, second type of problem related to steam table. Okay, so that is all about the steam table. You can do some more problem with the steam table later. Okay, so now I am moving to the next topic, that is half section of our module is completed. Half section of our module for the module is completed, that is steam table problem or PV diagram or phase transformation. So phase transformation, pure substance and phase transformation are topic. Half of a module related to phase transformation from a water to steam or something on a liquid steam to steam, liquid to vapor. PV diagram, HS diagram, TS diagram, etc. Diagrams are the steam table is there, Mollier diagram is there, problems related to steam table and Mollier diagram is there. That is the half of a module. And next half is related to ideal gas and real gas. Ideal gas and real gas. Ideal gas and real gas. So what is an ideal gas? Ideal gas. So ideal gas is nothing but this is a gas which obeys the equation of state, right? The equation of which a gas which obeys the equation of state, or this perfect gas equation PV equal to RT. PV equal to RT എന്ന ഇക്വേഷൻ ഒബേ ചെയ്യുന്ന ഗ്യാസിനെയാണ് ഐഡിയൽ ഗ്യാസ് എന്ന് പറയുന്നത്. ദാറ്റ് ഈസ് ഐഡിയൽ ഗ്യാസ് ഈസ് എ പെർട്ടിക്കുലർ ഗ്യാസ് or gas which obey equation of state. That is PV equal to RT. PV equal to RT. If M is the mass, we can write PV equal to MRT. If N is the number of moles, we can write PV equal to nRT. Okay. PV equal to RT. Small v is there, right? Small v is there, not capital V. Small v is specific volume. V equal to specific volume. P equal to pressure. R equal to characteristic gas constant. That is 0.287 kilojoule per kilogram Kelvin. T is the temperature. That is the equation of state. So how we can obtain the particular equation of state? So how we can derive or how we can obtain a particular equation of state or ideal gas equation? Ideal gas equation or equation of state or equation of perfect gas PV equal to RT. How we can obtain? So here we can write the particular equation or derive the particular equation in many form. So here in your textbook of Rajut is shown that it is by two laws. PV, the ideal gas equation or perfect gas equation, is derived from two basic chemistry laws, that is Charles law and Boyle's law. So I think you have already studied the particular laws in our +2 chemistry, like that. Boyle's law and Charles law. So what is Boyle's law? Boyle's law says that volume of given mass of a perfect gas, volume of given mass of a perfect gas is inversely proportional to absolute pressure at a constant temperature. This constant temperature, volume is inversely proportional to pressure. That is the Boyle's law. Okay, and here we can add V proportional to 1 by P. P അങ്ങോട്ടേക്ക് പോകുമ്പോൾ PV equal to constant. PV equal to constant. That is the equation for Boyle's law. PV equal to constant, which means that P1 V1 equal to P2 V2 equal to P3 V3 equal to etc. That is PV equal to constant. And this is Boyle's law. And what is Charles law? Charles law at constant pressure. Charles law at constant pressure. It is a constant temperature, and Charles law is at a constant pressure. That is at a constant pressure, the volume is directly proportional to absolute temperature. Volume is directly proportional to temperature. So Boyle's law says that at a constant temperature, volume is directly proportional to pressure, and Charles law says that at a constant pressure, volume is directly proportional to temperature. V proportional to T. That is V by T equal to constant. V by T equal to constant. That is, like this we can write V1 by T1 equal to V2 by T2 equal to V3 by T3, etc. So for a process, by combining these two laws for a process of unit mass, for a process of of unit mass, we can combining the both laws, we can write PV by T equal to constant. PV by T equal to constant. PV by T equal to constant. For a process, we can take PV by T equal to what is P1 V1 by T1 equal to V2 V2 by T2 equal to V3 V3 by T3, etc. PV by T equal to constant. So PV by T equal to constant. So we can write the particular value of constant as characteristic gas constant or specific gas constant. PV by T equal to a constant equal to R. That is specific gas constant or characteristic gas constant, or characteristic gas constant, that is R. The value is 0.287 kilojoule per kilogram Kelvin or 287 ജൂൾ പെർ കിലോഗ്രാം കെൽവിൻ, 287 ജൂൾ പെർ കിലോഗ്രാം കെൽവിൻ. അതാണ് ഇത് പ്രോപ്പർലി യൂസ് ചെയ്യുന്നത്. കിലോ ജൂൾ വരുന്ന സമയത്ത് മാത്രമേ നമ്മൾ കിലോയിലേക്ക് കൺവേർട്ട് ചെയ്യൂ. സോ PV by T equal to R. That is, R is a constant. PV, small v is there. PV by T equal to R. That is implies PV equal to RT. PV equal to RT. That is the ideal gas equation or equation of state derivation. PV equal to RT. സോ ഓരോ ടൈപ്പിലും ഡെറിവേഷൻ വരുന്നുണ്ട്. അത് നിങ്ങൾക്ക് നിങ്ങളുടെ ഹാൻഡ് നോട്ടിൽ അതാണ് തന്നിട്ടുള്ളത്. ഓക്കെ, ഇത് രണ്ടിൽ ഏതെങ്കിലും നിങ്ങൾക്ക് എടുക്കാം. ഇറ്റ് ഈസ് ഗിവൺ ഇൻ എ ഹാൻഡ് നോട്ട് another type of derivation. 3 സ്റ്റെപ്പ് ഇതുപോലെ തന്നെ 2-3 സ്റ്റെപ്പ് derivation. It is not using by Charles Lavande whilst it is given in your handwritten notebook. And another way of particular calculation is here, PV equal to RT. Okay, PV equal to RT. If M equal mass, it is for M, mass is called unity. Mass is called unity for 1 kilogram. So if mass is there, we can write PV equal to MRT, right? If mass is there, we can write PV equal to MRT. PV equal to MRT. So if N equal to number of moles, if N equal to number of moles, we can write PV equal to NMRT. That is, for a mass M process anengil, we can write NMRT. If M equal to 1, there is N anengil, PV equal to NRT. So NM into RT. So for last session, I told about a universal gas constant G or R naught, anything. That is M into R. Mass into R. Mass into R, we can take PV equal to N R naught into T. Or we can write R naught or G or R bar. പല ടെക്സ്റ്റ് ബുക്കിലും ഈ 3 പേര് ഏതെങ്കിലും ഒന്നാക്കി യൂസ് ചെയ്തിട്ടുണ്ടാവുക. Some text book it is used as R naught, some text book it is known as G, and some text book it is known as R bar. Everything you can write R naught equal to universal gas constant. Universal gas constant. The value will be 8.314. 8.314 kilojoule per kilogram molar Kelvin. Kilojoule per kilogram molar Kelvin. Okay. PV equal to N into R naught into T. Okay, PV equal to N into R naught into T. So, ഈ number of moles വരുമ്പോൾ ക്യാപിറ്റൽ V ആവും കേട്ടോ. ക്യാപിറ്റൽ V ആവും N വരുമ്പോൾ. എങ്ങനെയാണെന്ന് വെച്ച് കഴിഞ്ഞാൽ small v equal to total number of volume divided by number of mole. V equal to V by N. This small v is specific volume, capital V is total volume divided by number of moles. That is V equal to V into N. Total volume equal to specific volume into number of moles. Okay, അങ്ങനെയാവും. സോ അങ്ങനെയാണ് ഈ ക്വസ്റ്റ്യനിൽ VV substituting for small v, we can write P equal to V by N equal to MRT. And ആ എന്നാണ് അങ്ങോട്ടേക്ക് പോകുന്നത്, that is PV equal to NMRT. Okay, so please note that for a question related to normal perfect gas equation, for a question related to normal perfect gas equation, we are using PV equal to RT equation and R is 0.287 kilojoules per kilogram Kelvin. If question is asking for a molecular weight, മാസിന്റെ കാര്യത്തിൽ എമ്മിന്റെ കാര്യത്തിൽ എം ക്യാപിറ്റൽ എം മോളിക്കുലാർ വെയിറ്റ് ഈസ് ഗിവൺ ഫോർ എ പെർഫെക്റ്റ് ഗ്യാസ്, ഒരു ഇനി ഗ്യാസ് നൈട്രജൻ ഹൈഡ്രജൻ എക്സെട്ര മോളിക്കുലാർ മാസും മോളൊക്കെ വരുന്ന പോലത്താണ് വി ആർ യൂസിങ് ദാറ്റ് ആർ equal to 8.314 kilojoules per kilogram molar Kelvin. For a simple perfect gas equation, that is for a mass 1 kilogram, for a question asking that for a gas is given in for a mass is equal to 2 kilogram, anything like that, we are using normal PV equal to RT equation and R equal to characteristic gas constant 0.287 kilojoules per kilogram Kelvin. Okay, if question is asking that molecular weight of hydrogen is given as molecular weight, if a question related to mole, molecular, molar, etc., we are using that PV equal to R naught equation, R naught, and relation for R naught equal to molecular weight M equal to MR equal to R naught. Okay, MR equal to R naught. So R naught equal to M into R. R naught equal to M into R. So molecular weight M equal to R naught by R. M equal to R naught by R is the relation. That is M equal to molecular weight R equal to characteristic gas constant or specific gas constant 0.287 kilojoules per kilogram Kelvin. And R naught equal to universal gas constant. That is the difference between characteristic gas constant and molecular gas universal gas constant. So it is a particular topic in your syllabus. That is characteristic gas constant and universal gas. What is the difference between characteristic gas constant and universal gas constant? So അങ്ങനെ ചോദിച്ചു കഴിഞ്ഞാൽ we can write a equation PV equal to NMRT, PV equal to NMRT, PV equal to MRT from a gas equation PV equal to RT. Then mass M is there, and PV equal to MRT, and total M into R, molecular weight or something mass into R is known as molecular some gas constant or universal gas constant R naught into T, M into R equal to R naught. So M equal to, or molecular weight M equal to, the relation between universal gas constant and characteristic gas constant is M equal to R naught by R. R ന്റെ value is R equal to 0.287, R naught or G or R bar, anything. In some textbook we are using R naught, in some textbook we are using G, in some textbook we are using R bar. Anything, it is universal gas constant value 8.314 kilojoule per kilogram molar Kelvin. മോളിക്കുലാറും മോളാറും വരുന്ന കേസുകളിലാണ് നമ്മൾ ഇതെടുക്കുന്നത്. ഓക്കെ, അതർ ക്വസ്റ്റ്യൻസ് വി ആർ സിമ്പിൾ ഫോർ പെർഫെക്റ്റ് ഗ്യാസ് വി ആർ യൂസിങ് PV equal to RT only. That is the equation of perfect gas or equation of state or ideal gas equation and characteristic gas constant and also universal gas constant also. Okay. Okay. That is all about. And what is okay for ideal gas? What is real gas? Real gas, the deviation of ideal gas. Deviation of ideal gas from its state. Deviation of from its state is called the gas of deviation is called a real gas. Real gas is something gas which is deviated from ideal gas. ഐഡിയൽ ഗ്യാസിന് ലോ ഉണ്ടാവുമല്ലോ, ആ ലോ ഒന്ന് ഡീവിയേറ്റ് PV equal to MRT എന്ന ലോ ഒന്ന് അല്ലെങ്കിൽ PV equal to RT എന്ന ലോ ഡീവിയേറ്റ് ചെയ്ത് പോകുന്ന ഗ്യാസിനെയാണ് റിയൽ ഗ്യാസ് എന്ന് പറയുന്നത്. ഓക്കെ, അറ്റ് ഹൈ ടെമ്പറേച്ചർ ഇറ്റ് ഈസ് ഹാപ്പനിങ് അറ്റ് ഹൈ പ്രഷർ ആൻഡ് ലോ ടെമ്പറേച്ചർ. അറ്റ് ഹൈ പ്രഷർ low temperature gas deviates from ideal gas law, ideal gas equation. Okay, at a at a low pressure ആണെങ്കിൽ എന്താണ്, at low pressure the real gas also obeys the PV equal to RT. At a low pressure real gas obeys Charles law and Boyle's law, or we can say simply ideal gas law. At low pressure, low temperature, the real gas obey Charles-Boyle's law or simply ideal gas equation. And at the higher temperature or higher pressure, the gas is deviated from ideal gas equation. That is PV equal to RT deviated the one, and that particular gas is known as real gas. Okay, so there is a equation of state for real gas. That particular equation is known as van der Waals equation. That is the only derivation in your particular section, van der Waals equation. That is the real gas equation or equation of state for a real gas. Okay, നമുക്ക് അടുത്ത ക്ലാസ്സിലേക്ക് നമുക്ക് കംപ്ലീറ്റ് ചെയ്യാം. So for this module, for this section, we have studied about what is ideal gas and what is real gas, and what is characteristic gas constant and what is universal gas constant, and what is equation of state derivation. What is the equation of state? PV equal to RT if mass is mold here, PV equal to MRT. If number of moles is also there, PV equal to nRT. If number of moles and mass is also there, we can call PV equal to N into M into RT. And M into R totally called as number of moles വരുമ്പോൾ മാത്രമാണ് അങ്ങനെ ആവുന്നത് കേട്ടോ. M into N totally called as N into വരുമ്പോൾ എന്താണ് നമ്പർ ഓഫ് മോൾസ് വരുമ്പോഴത്തേക്ക് ആ മാസ് മോളിക്കുലർ വെയിറ്റ് ആവും. അത് ഞാൻ പറയാൻ വിട്ടുപോയോ. നമ്പർ ഓഫ് മോൾസ് വരുന്ന കേസിൽ മാസ് സാധാരണ മാസ് ആയിരിക്കില്ല, മോളിക്കുലർ മാസ് ആയിരിക്കും. നമ്പർ ഓഫ് മോൾസിന്റെ കേസാണ് മോളിക്കുലർ വെയിറ്റ് ആയിരിക്കും. അതാണ് ക്യാപിറ്റൽ MRT. ടോട്ടൽ ക്യാപിറ്റൽ M into R is known as universal gas constant. That is molecular weight into characteristic gas constant is known as universal gas constant. മറന്നു പോകാതിരിക്കുക. Please mark it as a very important term and please make it in a box. M equal to R naught by R or G by R or R bar by R, anything. Okay. So please give me your attendance now.